All right, we are recording now.
Excellent. So can you make me presenter? Can you?
Yep, I'm stopping sharing so you can, now you are the presenter.
It's saying host disabled participant screen sharing.
One second.
Hi, Vamsi. Hi, Hari.
Hi.
Hey, Deepak.
How are you, Deep?
Good, good.
Maybe you can make me host for
that's what
this
I'm
few
trying.
minutes. The participants.
Now try Venkat.
Yep. Thank you, MC. Yep. Yeah. So, good afternoon, everybody. Hope you guys are all doing fantastic, as always. So today, we've been talking about this AWS and mainly preparing for the certification. So we talked 2 review sessions. So today is going to be the third and the last. So before we talk about it, so we can make it as conversational as possible. So you can always speak. Okay, you can interrupt me, not a big deal, especially today. Because it's mostly the miscellaneous stuff, in addition to a couple of important aspects. So the main topic that we talked in the session 2, the last session, was VPC, virtual private cloud. So having your own, pretty much, having your own data center in cloud. So we talked about that with VPC. We can briefly, go over this again. So it's a logically isolated, section of cloud just for you. So you can define your own subnets, you can define your own route tables, etc. And we talked about, how router comes into picture. So when you create a new custom VPC, how the implicit router is created and attached, and that's responsible for routing the traffic by looking at the rules defined in route tables. And we talked about the NATO network ACL. So the network ACL, it's a virtual firewall for the entire subnet. Okay. So the difference between network ACL and security group is security group acts at the instance level, but network ACL acts at the complete, it acts as the police guard for the entire subnet. So we created public-private subnet. It's very important going into the exam to be able to do this one. Create 2 different subnets in 2 different availability zones. Subnet cannot span multiple availability zones. I'm just repeating it one more time. But you can have several subnets within an availability zone, but subnet cannot span multiple availability zone. Essentially, you will have your route table associated with the subnets. You can only have one route table associated to a subnet, and similarly, one network ACL can be associated to a subnet. Okay, by default, your default route tables get associated, which allows only the traffic to every instance within that VPC. That's the default route table behavior. And the default network ACL allows all the traffic. So you have to start putting your rules there. And network ACL, we need to understand it's a numbered rules. So it starts from, in ascending order. So it evaluates the rule number 100, for example, first, and then 110, 120, or 200. Okay? If 100 allows, it allows it. So if you want to deny any of that, any of the specific IPs using network ACLs, you will be able to deny using NACL. You can deny traffic to a subnet using network ACL. You will not be able to do that using security group. At the instance level, you will not be able to deny it. So yes, you can deny it, but you have to put your deny rules before the allow rules. That's the key. So be prepared for that. Expect some questions there in the exam also around that. After that, yeah, we provisioned, now we can provision EC2 instances in both public and private subnets. And just by defining your subnets, just by naming your subnet as public subnet, it doesn't become public. Public means you have to have a route out to the internet. Okay, how do you get it? Through internet gateway. So you have to create an internet gateway, attach to your VPC, and then update your public subnets route table and create a new rule there saying all the traffic will flow through the internet gateway. So that's how you update your route table. That's only attached to the public route. Your private subnet still has only the local route. So private subnet will not have internet. So it will not be able to take the request from internet. Similarly, it will not be able to go out to the internet for any operating system level patches or software updates or any of that. So it doesn't have any internet connectivity at this point. So yeah, that's how it works. So your internet gateway is acting as a front gate for the entire VPC that actually takes the traffic from internet. Okay. So how about security groups? Sure, security groups are at the instance level. If you look at it, so security groups are instance level. And we talked about NATs. Let's talk about NATs. So the objective here is that after going over the security group, after network ACL, the objective is here, my private subnet needs internet. So yes, my private subnet instances, they are all the app servers on the database servers, they will be in private subnet. They are not going to be in WebDMZ, meaning they will not be able to take the request from internet. Very fair. But they need internet to go out. They need to be able to go out and get the operating system level patches or any software. It needs to be able to do it. But with the current setting, I don't have it. And I don't want to update my route table and add internet gateway route to my private subnet route table, because I don't want two-way internet traffic. I want only one-way. Outbound internet, I need it. Inbound, no. So how do I achieve that? Well, you have to create either NAT instance or NAT gateway. There are two options. NAT instance is exactly like a EC2 instance. If you go search for Amazon machine images or AMIs, you will find a lot of NAT instances already. You pick up one of the NAT instances, but you need to put that NAT instance in your public subnet. Please understand that going into the exam. You can't keep the NAT instance and NAT gateway in private subnet and somehow, expect magic to happen. There's no magic there, pretty much. So all NAT does is, it does the network address translation. So when private subnet tries to go out to the internet, it flows through the public subnet, because you are going to update your route table to flow it through the NAT instance or NAT gateway, which happens to be in public subnet. So the packet will flow through the NAT gateway or NAT instance, and that will actually do the network address translation and then send the packet out again through the same internet gateway. So internet gateway is the one that sends the packet out. There's no doubt about it. But it feels that, okay, it came from NAT instance, which happens to be in public subnet. So it doesn't know that it actually originated from an instance in private subnet. So that's where the masking happens. That's where the natting happens. That's why they call the NAT instances a NAT gateway. But it's not a good idea to rely on NAT instance, because NAT instance is a single EC2 instance. There is no resiliency or failover there. Fault tolerance is not there. So that's why I use NAT gateway. Gateway is a redundant gateway. If one is down, the other one will be available. So if you use NAT instance, you're taking a chance, because your private subnet may not have internet if that NAT instance happens to be down. Well, you can apply the same resiliency techniques, put the auto scaling group, all of that, but you don't need to do all of that. You just use simply NAT gateway. Amazon is already providing you. So that's the idea there. And then you update your route table. You update your route table to and add your NAT gateway ID as one of the routes here. So this is how your private subnet gets the internet. See that? This is NAT gateway. I placed NAT gateway in public subnet and then updated the route table. All set. Now the situation is private subnet instances are able to go out and update the operating system level patches. Sure. But how will I be able to log in? Unfortunately, the inbound packet cannot come in because it's not attached to the internet gateway. So how will I be able to do that? Well, that's where the bastion hosts or jump boxes come into picture. So what you need to do is you have two-way internet to your public subnet. So log into the instances in your public subnet, and from there, you can log into the private subnet. Well, one simple solution that probably comes to our mind is, probably I'll keep my private key here. So my private key of this private subnet, I'll place it here so that I'll be able to SSH into my private subnet. That's a bad idea. Rather, use your bastion host or SSH agent forwarding. So with SSH agent forwarding, what happens is you are not keeping the private key in those instances, in the public instances. Okay. Rather, you'll actually put them you'll actually put them as a tree there. Pretty much, you will provide your private key of the public subnet and also provide the private key of your private subnets. So that's how it maintains that stack, and then it will let you log in. It's called SSH agent forwarding. There are some tools out there. Mac or any of the SSH agents by default support that, and Windows has some other tools. Okay, it's called PGN. So you can use that and you can log in. You can experiment it going into the exam. Try once, understand how it works. I recommend that. So that's about it. Before we talk about VPC peering, right? So this is where we stopped in the last session. So any questions on that? Okay, if you don't have any questions, I want to add one point. Somebody has a question?
Venkat.
Yes.
Yeah, this is Ketan. Now they have added a new thing right now. Mm-hmm. They have added a security group level on the VPC level. There's something brand new. I checked that yesterday. So basically, as soon as you create a VPC, there is a new thing is called a security group at the VPC level now. And I have not experimented how it works though.
Gotcha. But for all practical purposes, please do not go into the exam with that mindset. Everything gets muddy. Okay, security group is only at the instance level, and you have to use network ACL at your subnet level.
Okay, thank you. Yep, thank you. Yeah, I wanted to be sure on that. Like, do we have to continue?
Absolutely. Absolutely.
Okay. Okay, got it. Thank you.
Please don't go with that mindset.
Okay, thank you. Yep.
Yep. So one point that I wanted to add here is that here I've been telling you that the packet always comes from the internet gateway. So internet gateway is acting as a front door for the entire VPC is what I've been saying. That's not the only route. Well, that is one route. If you're exposed to the internet, definitely your internet packet will come in through the internet gateway, no doubt about it. But your VPC does not have to have internet gateway. So there is another one called VPC gateway. Okay, so what happens, the difference between internet gateway and VPC gateway is that, so let's say you have your VPC in AWS, and now you have your data center. So you have your on-prem data center. So you're fully not ready for the public cloud. So the way you guys set up is that you have a VPN tunnel set up between your data center and your VPC in AWS. So when you set up the VPN tunnel, on the AWS side, the front gate, that is called VPC gateway. So either you can have an internet gateway, which takes the traffic from the public internet, or you can have a VPC gateway here, which will take the traffic from the VPN tunnel, which could be your own data center on the other side. Does that make sense? So please understand that going into the exam. So either you can have an internet gateway attached for the public internet, or you have your VPC gateway. VPC gateway is acting as a router on the Amazon side of VPN tunnel. So obviously when you set up VPN tunnel, you have both the routers. You have your data center router and you have your Amazon router. So the Amazon router is nothing but your VPC gateway. Please understand that, okay? So now let's talk about this concept called VPC peering. So let's say you have two VPCs, and you can set up the connection between these two VPCs, okay, using that VPC peering connection. VPC peering is entirely possible, and it's a good idea. Actually, you could be using it in some cases when you have a partner network. When you're dealing with, let's say, in an acquisition, one company acquired the other company. They happen to have separate VPC, and these guys have a VPC. And if their IP address collision is not there, then you can, using VPC peering, you can pretty much form a mesh in such a way that everybody gets the feeling that the instance on the other VPC is inside my VPC. So you don't get the feeling that, see here, in this case, VPC-A and VPC-B, 10.0.0.0/16 is a VPC-A, and the VPC-B happens to be using a different private IPs, 172.31.0.0.0. So they are in two different IP ranges. There is no IP collision there. Then you will be able to set up, and you will be able to set up the VPC peering for all practical purposes. And you have your /16, meaning you have your 65,000 instances on the left side, VPC-A, and you have another 65,000 instances you could have, right? /16 CIDR block results around 65,000 IPs, unique IPs. So both of them can give you an impression that it's all single VPC. So please understand that going into the exam, you can do a VPC peering. And the most important point here for the exam and practical, the real life also, is transitive VPC peering is not allowed. Meaning, A has a VPC peering with the B, B has a VPC peering with C. So it's tempting to think that A will get connectivity automatically from A to C, through B. Transitively, it gets the connection. It does not work that way. If A needs to talk to instances in C, then you have to set up an exclusive VPC peering. So transitive VPC peering is not allowed. If A can talk to B, B can talk to C. Okay, if A needs to talk to C, then you need to provide a new VPC peering between A and C. There is no way, the transitive peering works. So understand that. Couple of tricky questions you can expect that. Especially, you should eliminate it. You have to use these techniques to eliminate your answers. So as soon as you see that, okay, through transitive, transitive peering, A will automatically get C. First of all, cross that. Say that this is a junk answer. Let's move on to. So you don't have to spend time on that. If you are not sure of the appropriate answer, please use these concepts to eliminate the answers. Okay, and there is another concept called AWS Direct Connect. So here you have your, again, it's like your VPN tunneling, but the difference between VPN tunneling and Direct Connect, again, the use case here is that you have your data center and you have your public cloud. Your organization is not ready to move the complete infrastructure into cloud yet. But all the new development is happening in the public cloud in AWS, but they have a decent infrastructure within their on-prem. So they want to be able to connect to it. VPN tunneling is one of the options, but that packet goes through the regular public internet route. So it uses the public internet, the regular backbone. But here with the AWS Direct Connect, so what you are establishing is you are establishing almost 1 Gbps. There are a couple of options there, 1 Gbps or 10 Gbps dedicated line between your data center and to your AWS. So in between your data center and your public cloud, complete your VPC or your region, at each region, or in some cases, there are other places also, there is something else called AWS Direct Connect location. There are some locations out there where you need to keep your appliance there. Okay, so you have to keep your router there and they will keep AWS router there. Okay, it's a physical setup has to be done. That's why it takes a long time. And then you have to sign your agreement saying that, I'm agreeing for this much bill and I'm agreeing to do the AWS Direct Connect. Okay, you have to sign with your, your organization has to sign the contract with them. And both of them will be in AWS Direct Connect location. So the traffic flows into your router here, okay? And from here, it's a dedicated backbone. So this is an option. If you don't want to use your public internet, and if you will definitely get your resiliency with the network, networking scenarios, and also you do not have these ups and downs in the network. You will always have a predictability in the network traffic because there is a dedicated line for you guys. You can buy your 1 Gbps line or 10 Gbps line. You can directly work with AWS on this one, on Direct Connect. Or if you do not have already your appliance set up in one of these locations, then what you can do is you can work with AWS partner network. They call it APN. So you can definitely work with the partner networks and then make sure this is set up here. And then they will set up there. And you have a dedicated line, pretty much. You're not using public internet here. So understand that going into the exam, the difference between your VPN tunnel and Direct Connect. Okay, that's about Direct Connect. And another important point going into the exam is the VPC endpoint. Okay, so you have your private instances, you have your public subnet and private subnet, you have your private instances. And let's say you do not want to provide any internet connectivity to these private subnets, private instances, either through internet gateway or NAT gateway, any of that, you don't want to provide it. But these private instances and private subnet needs to be able to talk to, let's say, S3 in a private way without going into the internet traffic. Okay, or it needs to be able to connect to the API gateway, Amazon API gateway. So how will I be able to do that without going into the internet? That's where the VPC endpoint come into picture. So you can create a VPC endpoint to these supported AWS services like your S3 API gateway and several other services that it supports. In fact, DynamoDB also. So you create an endpoint there, and now you set up that. Now you can talk to S3 from your private subnet through that endpoint. So once that endpoint is set up, you are not going through the public internet and then going into the S3. Even though S3 is exposed to the public internet, you are not going in that route. You don't even have internet. It does not leave, the network packet does not leave Amazon network. So it does only go through the Amazon network and makes it possible. So if your private instances within your private subnet, if they need to talk to other AWS services without having any NAT device or VPN connectivity or direct connect, how will I be able to do that? Using the VPC endpoint. Expose your AWS service as a VPC endpoint and connect to it. I recommend creating one VPC endpoint at least, probably to your S3 bucket, and then try connecting to it from your private instances from within private subnet. I recommend doing that going into the exam. So that's about the VPC section. Is that it? Probably not, but is that most of it? Absolutely. So did I cover every single point in VPC? May not be, but it's enough for you to go into the exam. So understand that. Any questions before I talk about Route 53? And undoubtedly, as I mentioned in the last session, so VPC is undoubtedly the most important topic going into the exam. So it's important. So if you don't have any questions, or I can even pause, if anybody wants to doesn't have to be a question. If you have any comments, additions, anything, please bring up. We can have conversation on that.
Hey, Venkat, this is
Yes.
Srinivas.
Mm-hmm.
So how much, what is the approximate percentage of questions covered
in VPC?
Under yeah.
In VPC, you should at least expect more than about 15%, I wanted to say.
Oh, okay. Good. Thank you.
Yeah. So it's very important.
Yeah.
Okay. And again, elimination is the key. Okay. And there is a small 6-7 minutes video on AWS Direct Connect. I recommend, having you watch that. So please watch that. It's once you put this diagram in your mind, and then because you'll not be able to connect AWS, you'll not be able to create any direct connection or anything. This is all expensive deal, and you have to sign the contract, and only organizations, big organizations can do this one. So you will not be able to practice this specific concept. Probably you can do, VPC tunneling also, but go into the VPC tunneling, go to the actually VPC gateway and try creating a gateway, and then understand at the high level what it is. It's very important concepts. And I'm sure VPC endpoint, you guys did it, and I highly recommend you do that. Okay. Now, so that's the story about VPC. Now let's talk about another important service from the exam perspective. It's called Route 53. So Route 53 is Amazon's DNS service. So this Route 53, it's a fancy name. They got inspired from this Route 66. So Route 66 was, the historical Route 66, probably about 2,500 miles or something. So they got the inspiration from Route 66. And then why did they use 53? Because the DNS port is 53. That's why they called Route 53. So it's Amazon's DNS service. So if you want to register your own domain, like my next step training. So this is where I have registered my domain. So you need Route 53. You have to go into Route 53, register your domain, and then this is how your the domain registration starts, and then managing their DNS also starts here in Route 53. Okay. So when you talk about DNS, understand your domain naming system. DNS stands for domain naming system. And DNS is all about simple key value pairs. It's like your phone book. Okay, in your phone book, what do you have? Your friendly name and your phone number. That is why you don't have to remember the phone numbers. So Vamsi, this is the phone number. I don't have to remember Vamsi's phone number, right? So similarly, when I go to Amazon.com, there may be a front end IP address. There is a load balancer that's sitting there, that's taking the request, and that's acting as a front gate. There is an IP address for that. I don't know the IP address of that, and I don't need to remember the IP address of that. So what browser does is, so what our DNS, the way DNS works is that, okay, it makes a DNS call. Okay, our computers have these DNS caches, and then if you don't have the DNS entry for that, meaning give me the IP address for Amazon.com is what you're asking. If you don't happen to have that in your DNS cache, then it will go to the next level. It will go to your internet provider, and then you'll ask them, saying that, hey, what is the IP address of Amazon.com? So it's a DNS hierarchy. It will go from there. If they don't have it, they'll go to the next level. If they don't have it, they'll go to the next level. So essentially, you have these DNS servers all over the globe. Everybody will have these records. It's a simple key value pair. What's the friendly name? What's the domain name and the corresponding IP address? If you don't have the true IP address, you will have something called a canonical name, CNAME, at least. And then based on that, you will be able to finally land in the specific IP address that you're looking for. So you will configure when you take the domain. Let's say I took this next step training and I have an EC2 instance there. And when somebody makes a call to HTTP GET, or somebody goes to next step training, I want that request to be taken by this EC2 instance. How do I do that? I do that in Route 53 by creating a record called a record. So this is where the authoritative record, so this is where you will specify that. For this DNS name, for this next step training, this is the IP address, 60.128.86.3. So now when somebody makes a request, now what they do is, okay, do I have the IP address of this next step training? No, I don't have it. Okay, then it does a DNS lookup. It will ask these DNS servers. So it will go to the nearest DNS server based on your geolocation. And those DNS servers will have the cached entry there. There is something called TTL, time to live. We talked about time to live when we talked about Cloud Foundry. So it's the same time to live. Your DNS entries will be cached in each DNS servers. So if you say that my time to live is 300 seconds, then it can be cached for 5 minutes. After 5 minutes, it will burst the cache and then ask for, can you give me a brand new, I'll make a brand new lookup now, and then say, can you give me the IP address of this particular domain name? Okay, so that's how the DNS works. And now Route 53 is Amazon's DNS service. So you don't have to buy the domain from them. You can have domain with someone else like GoDaddy. You can buy that. You can transfer there's something called name server records. You can have those name server records here, but you can manage them as a DNS service within Route 53. You don't have to buy from them. When you buy, what you get is essentially the name server records, NS records. Meaning who can give you that lookup, name, domain name to IP address lookup, essentially. So that a record is where your domain name will be associated with the corresponding IP address. So with the Amazon Route 53, there is a different concept called within an A record, you can also have an alias. You don't have to have an IP address per se. You don't have to have an IP address. Let's say next step training, I want to pass it to an application load balancer. And I don't have to have the IP address of application load balancer. You select that alias there, and then you can select your application load balancer instance there. Then when somebody makes a request to next step training, when somebody asks for a DNS, hey, can you give me the DNS record? It will give you that alias there, your application load balancer's alias. And then it will make an additional call. Okay, this is my application load balancer DNS entry. Now, can I get the IP address? That's how it works. So there is a concept called a record with alias and without alias. Without alias is where you will set up your IP address. You do your mapping there, the domain name to IP address. And in addition to that, there are a lot more records. Let's say you want to set up your mail servers. Let's say you are using Google Apps for your email. Let's say you're using Gmail for your company's mail server. Then you have to set up your MX records, mail exchange, your mail server records. Okay, so you'll specify your A records, SOA records, NS records, MX records. All those records will be there in something called hosted zone. That's what they call it. So once you go into the hosted zone, that's where you'll specify. For all practical purposes, this is like your DNS control panel in any of the popular services out there, like GoDaddy. That's all it is. But it's much more powerful than that. I'll talk to you. What's the power of Route 53? So when you configure your A records, so here you can specify different routing policies. How do you want me to route the traffic? So when somebody asks for an IP address of nextstep.training or amazon.com, what IP address do you want me to give it? Of course, you can have a simple static list of IP addresses. You can definitely have that. Or you can have an application load balancer there, or you can have an S3 bucket there. This is all simple. But you can set up much more complicated routing policies there. So there are different policies, and undoubtedly one of the most important aspects going into the exam. So they expect you to really know all these routing policies and expect some scenario-based questions there. So the first one is simple routing policy. As the name says, it's a simple. So you can only have one record. When you select your simple routing policy, you can only have one A record. Okay, then let's say I don't have an application load balancer, but I have these several IP addresses, several distinct IP addresses. How can I do that? Well, you can specify multiple lines within that within that single A record. You can specify one IP address. In the next line, you can enter your second IP address, third IP, fourth IP, like that. But you can only have one record. So when somebody asks for DNS entry, hey, what's the IP address of this guy? Then it will randomly pick one of them and gives it to the user. So you will not be able to configure health checks for simple routing policy. So there is a concept of health check within Route 53. Yes, you can configure your Route 53 for health checks also to see if that instance is healthy or not. If it is healthy, it will give that IP address. If it is unhealthy state, then you can apply the rules there. But simple routing policy does not allow that. Understand that. So there is another routing policy called weighted routing policy. It's based on weights. So essentially what it does is it splits the traffic based on some assigned weights. So you can say that, let's say I have 3 application load balancers, one in US East. Oh, by the way, Route 53 is a global service. You have to know that, right? So it will have access to all these application load balancers, S3 buckets, everything across the globe. It's a global service. So let's say I have an ALB, application load balancer, in Ohio region, Oregon region, and Frankfurt region. I can split it. I can split my traffic, saying that 20% of the traffic should go to Ohio, 40% of that it should go to Ireland, or what did I say just now, Frankfurt region, and the remaining 40% should go to Oregon region. You will be able to set that up. So the way you define is multiple A records here. So you will say that this is my A record and this is the IP address, our application load balancer alias, and 40% of the traffic should go to this one. And you will create the second A record and say that an additional 30% of the traffic should go here. And Route 53 will split it. When somebody asks for DNS record, it will pick that based on the weighting. Okay, 40% of the people will get this IP address, and another 30% of the people will get this, another 30% will get the different IPs. So you're able to distribute the traffic across all of them. That's called weighted routing policies. So where do you use this weighted routing policies? Well, let's say you have a new piece of code. Let's say you are deploying a brand new feature and you don't know if it works or not. What you do in that case is that you want to send 10% of the traffic to your new piece of code, or new application load balancer. And then 90% of the people will get to the old piece. 90% of the requests will go to the old application load balancer, which will not have this new feature that you are testing. So you are testing with the 10% of the population and collect the data and see if it works or not. If it works, go distribute it across all the 100%. If it does not work, you can make a step back and then say, what's wrong with this one? Maybe your assumptions are wrong, and go back and think about it. It's an important strategy. You can use it. And the third one is latency-based routing policy. So what happens here in the latency-based is you will specify different application load balancers. Again, I'm taking application load balancer as an example. It doesn't have to be that, but you have different regions there. You are specifying, you will configure multiple A records here. And you will say that, it's a latency-based routing. Okay. And what it does is, when you make a request, when somebody makes a DNS lookup, what it does is, okay, let me see this guy, I got this request, this DNS origin, they call it DNS origin. So let's say I made a DNS lookup from Troy, Michigan. So this guy made a DNS inquiry from Troy, Michigan. And how can I quickly serve him? What route will be the least latency? So he configured, there are 3 application load balancers, one in Ohio, the other one in Oregon, the other one in Sydney. So based on the timing, at that time, it will find out, okay, based on the internet routing and all, it will find out, okay, how can I serve him with the least latency? It will pick up that load balancer's IP and pass it to the caller. And then he's stuck with that until DNS gets expired. So he will keep going there. So if somebody makes a request somewhere from Hawaii, he will get from a different, again, based on the latency. It's not based on the geolocation though. How can I serve him? So maybe Hawaii people can be quickly served with the Japan-based, ALB than, Ohio, even though geographically it's part of US. Does it make sense? So it's a latency-based routing policy. So Amazon estimates it. It takes about 30 milliseconds. Okay, if I go with this route, it takes about 120 milliseconds. So let me give the IP address of this ALB, which I can serve with 30 milliseconds. That's how it works. So the next one is failover routing policy. So all the architects, probably you guys know this concept already. There are 2 kinds of architectures. You have your active passive architecture, or you have your active architecture. So let's say you have your east and west regions. So you have your two data centers. Your east is active right now. Your west data center, your west region, is out there in a passive mode. It is not actively serving the traffic. It will start picking up the traffic only when active is down. If active load balancer is down, then Route 53, through the health checks, it will find out that, okay, active guy is down right now. So active data center or active load balancer, the front gate guy, is down for whatever the reason. Now, let me switch it to the passive guys. So you will set up both active, you will set up as one active, the other one as a standby. And it will always send it to active as long as active is healthy. But if active is unhealthy, for whatever the reason, it will send all the traffic to standby region or standby data center. So this is called active passive architecture. And this one is a failover based routing policy. You're failing over in case of any disruptions to the active data center service. So the next one is geolocation based routing policy. So this is, as the name says, it's based on the geolocation of your end users. How do I know? Well, again, based on the DNS entry. So somebody made you DNS lookup, right? What's the IP address of Amazon.com? You'll find out, okay, where did this request originate from? Okay, it originated from Columbus, Ohio. Okay, now you can specify these A records based on, within Route 53, you will say that, hey, this is a geolocation based routing, and I want all the Americas, all the Northern America people, all the requests coming from Northern America should go into this application load balancer. All the EU requests should go into my Frankfurt region. All the Asia Pacific people should go into Singapore region. You can specify all the geolocation. You can specify the continents. You can specify the countries also. So now based on the geolocation, you'll be able to send it. So a request come from, for the same Amazon.com, a request come from, let's say, somewhere near Frankfurt. They will be able to see that in French, or all the European Union. That's how we defined our geolocation, right? So all the European will have a completely different website compared to your Americas and your Asia Pacific. So you can deploy multiple applications, your languages, your currencies, your dates, all of that can be, that skin can be changed in your application. And all Route 53 does is, it gives the appropriate, the IP address. Oh, this request was made from Asia Pacific. Let me give him the Singapore IP. This request is made from Americas. Let me give him Ohio IP. So Route 53 does that. Now, the next one is, it's a more complicated geo-proximity routing policy. It's pretty complicated one. It is based on the geolocation of end users and also the geolocation of the resources that they're requesting from. So, like your algorithm, you can define your traffic flow. When a request comes in, look for this, and then look for this, and then first check your geolocation, and then check for where my resource is, and check for this one. So you can write pretty much, visually you can write a code. It's pretty complicated. And you can also specify your, in special circumstances, you can use your bias. I have a bias for this specific area. Everything goes into this rule, but these guys, I want to give them, special privilege. So you can define your complete traffic flow visually within Route 53. You can define that complex flow. So going into the exam, you understand that geo-proximity is the most complicated one. You can use these biases and all, but do not expect any deep level questions on this one. It's a simple questions on the routing policies only, but it's very important to understand that when you see failover routing policy, you have to, it immediately should click. It's an active passive or active standby. There are two names for that. Active passive or active standby architectures. So it will always serve the active, but when active is down or unhealthy, then only it will start going to passive. There is no routing, there is no weighted there. But in the case of weighted, 40% of traffic will go here, 30% of traffic will go here, and 30% of the traffic will go here. That's where you can test your new piece of code to see what kind of response you're getting from your customers. So geo-proximity is pretty complicated. You can specify the complete traffic flow visually. You can diagram it. And there is another one called multi-value routing policy. It's a simple one. It's like simple. Remember I told you in simple case, you can specify only one A record, but within one A record, you can specify multiple values, the line separated values, IP1, IP2, IP3, IP4, like that. With the multi-value routing policy, the good thing is you don't need to have a one A record. You can have all 4 A records. So now you are having 4 A records, and it will randomly select one of them. And then the important thing here is that you can define health checks for all 4 of them. And see if one of them is, if you define your health check, if one of them is kind of down for whatever the reason, it will start randomly sending it to the other 3. The 4th one will not give that IP to any DNS inquiries because Route 53 identified that this is unhealthy. It's very important to understand this. So please understand that, okay? Going into the exam, the most important piece from Route 53 is routing policies. Any questions, comments, or anything that you observed? Go ahead.
Venkat.
Yeah.
So let's say example, weighted routed policy. You said I have a 3 application load balancer ALB. I have 3 application load balancer in different region, obviously.
Yeah.
Because now how do I able to configure my A record with all 3 application load balancer.
That's correct.
Oh, is it? So if
Absolutely. You will have 3 A records. Let's call them, for example's sake, here ALB1, 2, 3. So you can configure 3 A records there. The same A record, you will say that weighted routing policy, ALB1, 40%. A record, weighted routing policy, 30%, ALB2, the third one. So we have 40 and 30. The remaining is 30%. So that's how you will distribute it.
Okay, yep, thank you. Yep, I will try that now.
Yep. Yeah, try that.
Yep.
So another tip that I want to give you, since you said you will try that, right? So if you want to try any of these geolocation, geoproximity is it's a little complicated one, but if you want to try the geolocation based, what I would say is use one of these VPN clients and then log in as if you logged in from, let's say, Singapore, as if you're logged in from Mumbai. The VPN clients will let you select that, then observe that. What kind of IP is it giving? Okay? That's a small tip for you to kind of test it.
Sure, Venkat. Yep, I will try that. Yep, thank you.
Yep. So now, with that, pretty much all the major concepts for the exam are kind of finished. So now there's a next generation of technologies, the serverless architecture. This is like if you're building something brand new in 2020, you should consider these architectures. So it's called serverless architecture. Let's take a look at it. So AWS has this service called AWS Lambda. Lambda comes under, so we have within cloud, you have this infrastructure as a service, platform as a service, and software as a service. So AWS Lambda comes as a different breed called function as a service. A simple function, you write your piece of code according to the spec, of course. AWS, Lambda, they define spec for Java, C#, all of these guys, okay? So you write your piece of code, upload your code into your management console. So you define your Lambda. So Lambda is a simple function, right? So now you can configure your triggering points. When should this Lambda be triggered? You can configure. Should this Lambda be triggered when I upload a file in S3 bucket? Is this specific bucket? Every time I upload a new file, meaning every time I do a HTTP put on this S3 bucket, trigger my Lambda function. And in the Lambda function, it will pass you the complete context as an input. Amazon automatically pass you. You take a look at the context, and then this Lambda, you can now you can do anything. Your piece of code got triggered. You can do anything. So it works perfectly well for your event-driven architectures. If you're thinking about, hey, I want to run this piece of code when this event, when this event gets triggered. I want to trigger this piece of code when this event out. How do I do that? That's where the Lambdas come into picture. You can safely use this as a decoupled architecture. Right now, you don't have to move your complete infrastructure into Amazon or AWS. You can safely use this Lambdas and then say that from your own data center, when certain conditions happen, you just trigger it and then call your Lambda, and then Lambda will do its job. So it lets you run code without provisioning or managing servers. That's the beauty here. You are not worrying about the servers. You don't know you have no clue about EC2 instances, containers, any of that. You just write a piece of code and it will infinitely scale. You don't have to worry about it. You pay only for the compute time you consume. If your Lambda is called only 5 times a day, you'll only be paying for those 5. If it runs overall for 50 seconds, you'll be only paying for that. That's the beauty. Just upload your code and Lambda takes care of everything required to run and scale your code with high availability. So you can set up your code to automatically trigger from other AWS services, or call it directly from any web or mobile app. I'll talk about this one. So the one I was saying is S3. So as soon as I upload a file into S3 bucket, I want my Lambda function to be triggered. You can set up that. Or when I make an HTTP API call, I want my Lambda function to get triggered. You can do that. So it comes under function as a service category. It's a great tool for event-driven architecture. So let's take a look at a couple of use cases I copied from as is from Amazon documentation. So take a look at it. It's a photograph is taken, and then you uploaded the photograph into S3 bucket. Your Lambda got triggered. Your Lambda runs image resizing code. See that the same image that you might have uploaded some 4K like video or high resolution pictures. So what it will do is it's a resizing based on your form factor. For your iPad form factor, use this size. Your iPhone form factor, use this size. For your desktops, use this size. It will do it. It's a perfect. Your piece of code is sitting there, and you'll only be charged when this gets invoked. So all you are specifying here is how much RAM do you need it? How much memory do you need it? That's the only one it's specifying. You don't have to worry about any CPUs or anything. It will automatically calculate that. Some use cases here. So you can use it as a web application. This is where the serverless application come into picture. So user clicks link to get local weather information. See that? So when you click on that, that's when it makes an API call. It makes an API call, and your API call is taken by API gateway. API gateway is acting as a front door for all of your APIs. That's where you will use your API gateway to manage your APIs, to create, to manage those, to apply all the cross-cutting concerns there. That's where API gateway comes into picture. And that API gateway will trigger your Lambda function. Your Lambda function is the one that's going into your RDS, probably, or you go to DynamoDB, wherever your end data source is, get the data, parse it, and give it back to API gateway. API gateway, you can either massage it or give it back to as is to your client. Make sense? This is a serverless web application. It's a great concept. It has its disadvantage, of course. It's debugging nightmare, because you have all over now. This Lambda got triggered upon receiving a request from here, but this Lambda trigger one more Lambda here, and this guy is doing something else. It's like you can complicate the architecture like that. So understand that. But for that, to ease that, Amazon has introduced a service called Amazon X-ray service. So X-ray service will give you the complete path execution. Where did the request initiate and where is it going? All the services that it touches in between. So it gives the complete flow. So your IoT backend, absolutely. So look at that. Proctor sensors send data to Amazon Kinesis, and Kinesis is a stream service, Amazon's stream service. And then after receiving the data, this guy triggers Lambda, and Lambda runs code to detect trends in sensor data, identify anomalies if something goes wrong with this tractor. Okay, and then it will identify based on the data it is coming from. Your Lambda can determine that, hey, too much temperature, it's crossing the temperature threshold from the radiator. Maybe something is wrong. It can actually place an order for that particular part. It can do that. So your smart cities. So let's say you have your traffic lights here, right? So you continuously send the data. You have your traffic, your light pole here, and there is an adjacent light pole here, for example. So if this guy continuously emits the data, and someone else, the like Lambda, will process the data, and it will find out that, okay, you know what, my neighboring my neighboring pole or my neighboring light is dead. So let me place an order in Amazon.com. So you can really do something slick with IoT backends with Kinesis. Kinesis is a stream, and then Lambdas. Really complicated, really good stuff, really useful stuff. Your smart cities, your smart cars, absolutely smart cars. Your Tesla cars emit a lot of data. All of that data through Kinesis, it will go into the cloud. And then you will trigger your Lambda function on it. Based on all of this data, it will realize that something is wrong with this one. Okay, let me place an order to, where is this location coming from? Okay, he's on I-80 East. So this is where his current location is. Okay, let me see the nearest service center there. And I can send out an event to nearest service center and then say that, hey, there is a Tesla that's coming on your way. Okay, be ready with this part. And then I can send a notification SNS notification to the driver saying that hey, something is wrong with you. And then I have already placed an order. So you go straight to this location. It's really futuristic. So you can do all of that. Mobile backend, it's the same stuff. So now the important point, all of that I said is to kind of excite you. It's a futuristic events. So, but going into the exam, right? So Lambda triggers. So you need to understand going into the exam, what can trigger Lambda function. An API gateway can trigger Lambda function. Your application load balancer can trigger Lambda function. Your S3 DynamoDB data change can trigger Lambda function. Understand that. Your DynamoDB, it's a non-relational database from Amazon. When you insert a new record or update an existing record, yes, it can trigger Lambda. But the last one, the important point here is you will definitely get 1 or 2 questions. Your RDS is not one of them. Understand that. Your relational database service is not one of them. He will say that, in the exam, something like your Microsoft SQL Server is your RDS, and then when the data is changed, you trigger Lambda. That's a red mark. As soon as you see that an RDS triggering a Lambda function, you should see that, nope, that cannot trigger Lambda. Absolute important going into the exam. So that's about the Lambdas. It's a lot of fun. It's a lot of fun architecture, but I can't cover everything there. Any thoughts at this point?
Venkat, quick question on that. Like, so, I mean, on 2 aspects, right? Like, I have 2 questions maybe.
Sure.
The financially, right? Like, so using the regular JVM and using the Lambda. Of course, Lambda has its own scope of using it, mainly where the data streaming or wherever the data streaming is happening. You want to transform something, or you want to do quick functions or something, and transform into something else, then it will be more apt to use it. But there is not much suitable if job is a heavy job, or not even maybe heavy job, like medium-sized jobs also, like maybe not suitable.
That's
right?
a fair point, actually. I think the maximum is 5 minutes. Okay. If I'm not wrong, you can, I believe it's configurable. You can do that, but that's a very fair architectural consideration.
Yeah,
you really nailed it. Yes, it's not
segregating where to use it, when to use it.
Absolutely.
And also the cost aspect, right? Like obviously, when I have like a huge volume, maintaining my JVM for a month and compared to that with serverless might be more costly, right?
I'm glad you mentioned it. Let me add a point or 2 there, okay? So one, let's understand what exactly happens when Lambda, okay, when Lambda gets triggered, what exactly is happening there? Let's open up the, under the hood, let's see. So what it does is, so actually, if you guys look at the evolution last 20 years, we went from the physical servers to virtualizations to, recently with containers, right? Containerization with your something like Pivotal Cloud Foundry, your Kubernetes, Docker images, all of that. And then the next level is your complete serverless, which is Lambda. So what exactly happens is, so when a Lambda gets triggered, it will check, do I have a piece of code running already in a specific container. If not, what it will do is it knows the appropriate runtime, right? Whether it's Java, Python, .NET, or anything. So it will spin up a new container based on the memory settings that you specified. It will spin up a new container. Container is a very lightweight. It's a very lightweight compared to your virtual machine, right? So it will spin up your new container and then deploy your piece of code and give you a request to that. And you may be thinking that the immediate question that should arise is, hey, isn't it slow? Because when a request comes in, and that's when I'm kicking off my bootstrapping happens. Absolutely, that's a very fair consideration. So that's where you can configure it. What you can do is you can start making the fake requests to health checks so that it will keep your container in warm state. Then you may be asking it, okay, then what's the difference between EC2 and this one? Another fair question. So that's where you have to kind of balance it, okay? Rather than running your 24/7 for a small, startup, right? For a small startup, running a medium-sized EC2 instance 24/7, 365 days, and only when I get few requests a day, that's where it's okay for having a couple of microseconds or a few microseconds additional performance. The reduction in performance, I'm okay with that, but I'm having, instead of 100,000 bill, I'm getting $500 bill.
Yep.
So it's a fair question. Thank you.
Thank you.
So let's talk about the next one is API gateway. I'm not sure how many of you are really familiar with this API gateway. API gateway, if you are an API provider, so API gateway is acting as kind of a front door for all of your APIs. And as an API developer or an API architect, what you will do here is that you will manage all of your APIs within this API gateway. So API, let's say you have 100 microservices here, right, in the background. And then it doesn't make sense to do authentication and authorization it doesn't make sense to put that authentication and authorization and other logging code in all these 100 microservices. It doesn't make sense. These are cross-cutting concerns. I'll move all of the cross-cutting concerns into the front layer called API gateway. So here, and it's not the only one. I can write very complicated policies there. And I can take care of authentication, authorization, all of that. And also I can do a traffic management. And if my APIs are popular, let's say whether APIs I'm getting popular, then I can say that, let's say Apple is utilizing my APIs. Okay, I'll configure Apple as one of the clients here. I'll give them a specific credentials. And let's say Apple is one of them. Let's say Google is another example who is using my popular weather APIs. And I'll create a separate one. I'll create separate credentials for that. And I'll also can cap them at the client level, saying you can only, to save my backend resources, I can say that, hey, I will allow only 300 requests per second. Google, I will allow only 200 requests per second based on it. And I'll be able to build them appropriately. All of that, your complete API management will be done in this thin layer called API gateway. It's a really, really beautiful concept. It's nothing to do with AWS. There are good API gateways out there. I have used one called Apogee, is one of the API gateway, and there's layer 7. And Apogee was actually eventually bought by Google. But Amazon is into a lot of these things. It's competing with all these people, right? So Amazon's API gateway, it's a simple. You can use this API gateway. So the combination of API gateway and Lambdas is where the power is, power of serverless architecture. So if you want to deploy your APIs, and if you don't want to have your EC2 instances running all the time, 24/7, 365 days, then put your API gateway, and the API gateway can trigger your Lambdas. So when a request comes in, API gateway will take it. Of course, it applies the policies, authentication, authorization, and other cross-cutting concerns. And then it will trigger your Lambda. Lambda is the one that does actual work, gets the data from whatever the data store that one is, and gives it to the Lambda. And Lambda can actually do Pre and post processing, meaning it can massage the data and send it back to the client. The API gateway can do that. So it's a fully managed service that enables developers to create, publish, maintain your APIs and monitor and secure APIs at any scale. It can interact with several integrations, like it doesn't have to be Lambda, but it can be Lambda, EC2. So benefits: traffic management, authorization, and access control, as I was mentioning. Monitoring, yes. And API version management, absolutely beautiful concept, actually. When you have your microservices here, right? So you can specify, let's say /customer is my customer microservice. So /customer/ let's say V1, like version 1, I can send the request to this V1 customer microservice. If somebody calls with /V2, I can send it to the other microservice. So you can manage that API versioning. Beautiful. When you have API version management, definitely think about any API gateway. It doesn't have to be AWS API gateway, but in general, any API gateway. And of course, you can throttle the requests to prevent attacks. So when you talk about API gateway, you have to understand certain jargon. So when you say API, within AWS API gateway, when you try to create these APIs, you just understand this jargon here. Collection of resources and methods together is called API. And resource is I'm hoping you guys are familiar with resource-oriented architecture. In ROA, your resource is the key. Your noun is the key. Your customer, for example. So /customer will give me all the customers. /customer /123 will give me a customer with the ID 123. /customer /123 /accounts will give me all the accounts of customer with the ID 123. So it's /persons, for example. Yep. Get HTTP get. Same URI /persons. HTTP get will give me all the persons. /123 will give me a person with ID 123. And the same URI, when I make a HTTP post, then mean I'm creating a new person. When I make a same API /person /123 delete, I'm deleting a customer. When I do a HTTP put, I'm updating it. It's nothing to do with AWS exam, by the way. This is all, I just put it out there out of my interest. When you create an API gateway, you will need to understand what an API is, what the resource is, and method is, HTTP method. And there is another concept called, somebody has a question?
Question. Sorry, this is Anand Venkar.
Hey, so I was looking for you. So
right.
If you guys don't know, he's the most knowledgeable person that I know on any API gateway. Oh, okay. Go ahead, Anand. I don't think...
Sure. About the post, right? We are creating a new resource. I see like the person ID in the URL. Yep. Does it make sense?
Yeah, that's a good point. That's a good point, because how do I get 1, 2, 3 when I do a post, right? Because the return is what I will, so the response, in the response, I will have the ID. Makes sense. Thank you. Thanks for making that. So that's a mistake. Absolutely. That's it.
Yeah, that's all.
Okay. So, and you have another concept called stage. Essentially, you have your deployment stages. You can create different stages when you create the API gateway, like dev, QA, stage, prod, etc. Okay. So at the high level, that's what API gateway is. So understand your API gateway. How do you achieve your serverless architecture? You have your API gateway with Lambdas. That's a beautiful way of achieving your serverless architecture. So have your Angular-based front end somewhere deployed. Okay, this is a beautiful web application, serverless web application. Have your Angular or some next generation JavaScript framework, okay, deployed. It's a pure UI content there. And now I have my Angular here. Now you're making an API calls. When you make an API calls, your API gateway is the one that takes the request. And and there is no EC2 instance running all the time there. I'm saving a lot of money because I get only few requests per day. Okay, then I'll configure that as a Lambda, and I'll configure my API gateway to trigger the Lambda after authentication and authorization is done. See, I'm only paying for those few minutes of Lambda resources. Really, you can save a lot of money there with that. Of course, you'll have to re-architect it. It's a different way of looking at things. But also you can complicate and can go wrong. So please be careful there. Mainly because of debugging nightmare. Okay, that's where you want to use services like X-Ray. Okay, so with that, let me spend a couple of minutes on everything else. So simple queue service, SQS. SQS is Amazon's #1, the first AWS service provided by Amazon years back. I believe it's back in 2006. So simple queue service. So that's why they don't let go. They will always invariably ask 1 or 2 questions in the exam. So simple queue service, it's a poll-based queue service. It's not push-based, it's a polling. You have to keep polling the queue. Is there a message there? Is there a message there? Like you have to keep polling it. So short polling and long polling, please understand that going into the exam. So what it means is when I poll, when I say, do I have any message for me to consume? When I make a call, right? What it does is, if there are no messages to consume, it will immediately return. That's the default behavior. It's called short polling. But if I configure it, that wait time seconds. So wait for, let's say 15 seconds. So what it does is, if there is no message for me to consume, if there is a message for me to consume, it will give me back the response immediately. But if there is no response, it will wait. It will actually make my thread wait until the expired time. So until my 15 seconds expiry is done. In my configuration, I set 15 seconds, right? So it will wait until that time is expired. Once the expiry is over, that's when I'll get the response back saying that, sorry, you don't have any messages. So with the long polling, I'm not wasting a lot of resources, just keep asking every single second. I made a call, it sent me response back that, sorry, there are no messages. I'm asking again, sorry, no response, asking again. So with the long polling technique, you can reduce your resources. Expect a question or 2 on that. And also please understand the difference between Amazon SQS and Amazon MQ. Amazon MQ is an active MQ in cloud. But SQS, we don't know the underlying, the message-oriented middleware mechanism is. Okay, it's whether it's active MQ or it's actually Amazon's custom messaging middleware. Okay, so for all when do I go for SQS and when do I go for Amazon MQ? Well, if you already have active MQ setup or some sort of MQ setup within your organization and you want to migrate it as is, you can't go to simple queue service or SQS without making a lot of code changes. That's where you want to go with Amazon MQ. This is like to be backward compatible and eventually change your application architecture if you need to, or you can safely use, this is a PaaS, platform as a service, MQ service within AWS. Understand the difference between those two? And you have your miscellaneous services. So CloudWatch.
One question.
Yeah.
From the MQ, can we trigger the Lambdas?
When I get an MQ, can we trigger the Lambdas? Very good point.
Yes,
so what
we can do that.
With the MQ, oh, thank you. Who said that?
Nara.
Okay. So yes, with MQ, you can trigger the Lambdas. Actually, you can trigger, what you can do is, in fact, the better way to use the publish subscribe model is you can post and you can publish an SNS notification and have SNS notification kick off your Lambda. That's even better.
SNS notification. Okay.
Simple notification service. It's a pub sub model.
Okay.
It's
So SNS will subscribe to MQ and that will trigger the Lambda.
exactly.
Okay.
So you have your so you have your CloudWatch. CloudWatch is your monitoring service. Your EC2 health or any of the application load balancer health. That's where the CloudWatch. You can set up your alarms there. If my CPU utilization of any EC2 instance goes above 80%, message me. So the way you configure it is you will configure an SNS topic. Okay. So CloudWatch will alert and send a notification to SNS topic. And SNS topic, there I can specify multiple destinations. My email ID, my phone number, or my customer's email ID, my customer's phone number. You can specify 100 things. That's the beauty with SNS, is your pub sub model. You can have several subscribers there. So that's a CloudWatch. CloudWatch is all about monitoring. And the CloudTrail is all about audit trailing. Going into the exam, it's a very critical to understand the difference between CloudWatch and CloudTrail. CloudTrail is all about audit trail. Who invoked this API when? Okay, somebody messed with my S3 bucket. Okay, who did it? CloudTrail. Or somebody created this new user. Who created it? Okay, somebody gave this role to this one. Okay, you have to, let's say you have compliance reasons and you will have to provide your complete audit trail to your auditors. CloudTrail is the way to go. And simple notification service, I already mentioned it, what it is. It's a simple pub sub model where you can send the notifications. ECS, Elastic content. Go ahead.
On the CloudTrail, is it just the app service kind of thing, monitoring, like all the rules and everything, or is it going to monitor even the data aspect also? What are all it's gonna record? What kind of level?
Right. So with the CloudTrail, it's what exactly do you mean by data? Let's start with that.
Yeah. So basically, like I added a user into probably a change from moderator to contributor. So
Yep.
that I will get audited here.
Absolutely.
Right? Mm-hmm. Yeah. So can I configure like in the app service level also, like probably who invoked the API gateway for this particular API?
Yep, absolutely. With who invoked this particular API, absolutely, that can safely go into the CloudTrail. In fact, it can get into little details also, with especially with the S3. It can separately write into a separate bucket. All the events can go into it, including at the data level. Yes.
Like a blob or something, you will create and then store all the information.
Yes, okay. Absolutely.
Makes sense.
And you can safely give that to your auditors in the mid-year or year-end auditors, for the compliance reasons.
Sounds great. Perfect. Thank you.
Yep. So ECS, EKS, Fargate, these three are kind of together. I'm not going in depth there, but your Elastic Container Service, Kubernetes Service, and Fargate. Container Service is Amazon's own mechanism of managing the containers. It's like a container orchestration. Amazon's own container orchestration. So we talked about physical machines to virtual machines to containers to your Lambdas or function as a service, right? Complete serverless. So these, but if you deal with containers, so you can use your Amazon's own container orchestration service called ECS, Elastic Container Service. Or if you have your Docker and Kubernetes, then you can go with Elastic Kubernetes Service. So this is where you can configure your Kubernetes as your container orchestration. And Fargate is an abstraction on top of your ECS and the EKS. It sits on top of it, and you can pretty much orchestrate it between ECS and EKS. So, and your Elastic Beanstalk. Elastic Beanstalk is Amazon's PaaS solution without having to worry about servers and all. If any of these runtimes, your Java, .NET, PHP, Node, any of these runtimes, you just write a piece of code and then deploy it, and forget about everything else. It will create, under the hood, it will create the application load balancers. It will set up the entries. It will do a lot of these things. It's a PaaS-based solution. It's not serverless though. Understand the difference. It's not the serverless. It will create for you. Since you are not technical guy, so Elastic Beanstalk is for less technical people. I just want to quickly have my WordPress site up and running without knowing, technical jargon. Beanstalk is for me. That's it, really. Yeah, that's
awesome.
That's it. We can absolutely bring any interesting discussion points. By no means this is everything though. I'm sure you guys know it, and I'm specifically saying it. Is it everything that's absolute needed for the exam? It's doubtful to say that, but is it most? Absolutely. I can confidently say that across all these 3 sessions, you can safely pass the exam, you can nail it. As Vamsi mentioned, is that a fast track? Absolutely, yes. I can give that much confidence.
As part of your training, I mean, are you providing any practice exams?
Yes, these guys know it. Yep, they have a practice exams, and we do in-depth labs.
Okay.
So on almost all of these concepts, we do it. We do, for example, Lambda right earlier. So I'm glad you asked that. Okay, so I can mention what we do there, right? I mean, differently. This is all just, I talked at 1,000 feet view. In my sessions, what we do is we'll actually go into it. So yesterday we were talking about auto scaling group. We'll actually look at every single aspect of it. How can you do a simple auto scaling group policy? How can you do a complicated one? And how can I have my CloudWatch trigger my auto scaling group? So all of that. So we'll really practice it. And I have if you look at the website, the next step training, you will go to the videos and batch 1, batch 2 videos. There I provide homework links. We'll do homework. So today they spent all 4 hours working on the various homeworks. Wow. So they will set up the complete application load balancer. They get very detailed understanding of all the services. Again, all, when I say all, not every service that Amazon provides, but whatever is needed for this certification. So they do pretty deep dive there.
Completely end to end. Thank you.
Exactly. No, thank you. And they will realize it. They will be able to kind of realize it. They'll start with EC2. They'll start with application load balancer. Eventually, into after you learn about Lambdas and API gateway and how a typical serverless architecture looks like, you get your hands dirty, get excited about it, and we even take one or 2 domains in the Route 53. I'll configure it. I'll show them. I'll show even my own website, how it is configured to various destinations. Your S3 bucket, how can you configure in Route 53, and your application load balancer, all of that. So we do that pretty deeply.
Could I just did the NS lookup for next step training portal. So that was showing me an IP address 35 dot something. So
Yep.
Right.
Yes.
2 questions, Venkat. One, it's not a question. This is a problem I'm working on. Just wanted to see if you have any suggestion on it. So we are using PaaS, of course. We have an app service, which is called like EC2, like the Beanstalk you said. We are exactly using that.
Okay.
But the problem which I'm going through is, we did not configure any, what do we say? We did not configure any load balancer, but Azure internally maintains the load balancer, right? So for every 4 minutes, we are getting a timeout on few requests, like all the requests I can say. Any request is idle for 4 minutes, it's getting a kicked out by, I'm thinking load balancer. I'm trying to look through this problem and come up with alternatives. Do you have any suggestions?
So every 4 minutes, so if it's ideal, if you pause it for 4 minutes, after 4 minutes, when you make a brand new request, your your load balancer is kicking off.
Right. Basically, we are not pausing. The stored procedure call is taking more than 4 minutes, just to keep it simple.
Oh, stored procedure call. Stored procedure call is taking more than 4 minutes. Oh, that's your the work with the network team. And is it completely public cloud, or is it?
No, it's not. It's basically
it's a
the
mix.
Misc.
It's a hybrid.
Yeah. Yeah.
It's a hybrid.
Yep.
Yeah. Then I'm guessing. Any others can pitch in here, but I'm guessing that's a firewall. Firewall is clipping the connection after 4 minutes.
Yeah, we spoke with the network team. They said like they are not configuring anything. They are saying probably Azure is controlling that. So that's where we are stuck.
I'm guessing again your network team are the other side, right? So the firewall is clipping the connection because that guy is taking more than 4 minutes. So load balancer is actually handling load balancer gave the request to the target, and then target did not respond within 4 minutes, right?
Right.
That's essentially what's happening there.
Yep. You got it.
Yeah. So, and you did not get it in 4 minutes. So you have to look at the load balancer. I don't know what load balancer you guys are using, but something like.
So we did not configure any load balancer, but Azure internally configured a load balancer to maintain its
exactly, because you're using PaaS-like solution.
Exactly.
But Beanstalk-like solution. Beanstalk, but under the hood, it creates it, and it will have the connection timeout also.
Yep.
You have your read timeout set to 4 minutes. That's what it is.
Yeah.
You have your connection timeout and read timeout, right? If my target does not respond within 4 minutes, I'll clip the connection. That's the very natural way of doing it with a lot of load balances as a matter of fact.
Okay. So what you're saying is we have to find out the load balancer settings and see if there is any way.
Exactly. Something like F5.
Yeah.
It's very simple, setting.
Yeah, the company which I'm working is big, so they don't get us involved in that kind of level.
Exactly. That's where I think you're. I would work with the network architect closely on that.
Got it. Okay.
Okay. I will exactly explain the scenario like how you did. So I'm making a request to this one. There is a front gate here, load balancer. Load balancer is handing over the request to the target, but target is not responding back within 4 minutes, and it's clipping the connection. So hence I get the read timeout. So
exactly, web application start time.
Yep. So once you lay that out, sorry, go ahead, Anand.
Yeah, I agree with you, Venkat. So they can also capture packets at the LB level.
Yeah,
right. Get to the bottom.
Right.
Got it.
So and being a solution architect, what we do is that we are jack of all. We understand the picture here, and then we work with the appropriate parties. So the network architect, hey, can you give me your 2 cents? Yeah, absolutely. Sorry, go ahead.
Perfect. Yeah.
Defaultly network team always says it's not us. That's when we need to push the trace network. Yeah.
Okay.
And that's when we need to force them to do network trace.
Okay.
Agreed. Yeah, that's what. Before getting there, it's not easy to get there. I have to do so many steps to
the
prove
same
that.
network team, right? Sorry to interrupt. They may tell you, can you try now? Then it will be
yeah, exactly.
No comments. Anand and I have some background. That's where that's where he was going.
Can you try now? Is like popular phrase.
Yeah. My next question is, I'm looking for some usage on this, like ADF, which is in AWS called the AWS Glue. So it's in Azure. In Azure world, it's called Azure Data Factory. In Amazon world, it's called AWS Glue. We have a data problem and we are trying to see if this can help us. I'm trying to get some knowledge on it. Have you heard anybody in the call have any?
Me, I can honestly say, no, I'm not familiar with it.
Okay.
I will have to, it's called Amazon Glue, you said?
Yeah, AWS Glue.
Okay, I can take up, but...
I heard Amazon Glue is the ETL substitute for
There you go.
Yeah, it's almost, yep, you're exactly right. Yep. In Azure world, it's called Data Factory, and we are trying to work on it to solve a few problems in future. It's basically, we get like 2 million records, 3 million records every month. We are trying to, after some number of months or something, we wanted to use this ADF and push the data there and retrieve on demand. So that's exactly the problem. We are trying to see if this can help us. Yep, thank you.
Yep, no problem. Sorry, I couldn't help there.
No worries. Yep, perfect, thank you.
Mm-hmm. Any other thoughts, comments?
Thank you, Venkat, for spending your time doing a lot of work to make this thing happen, and patiently explaining everything and answering everybody's questions.
My pleasure. My pleasure.
Yep.
No,
Thank you, Venkat. Thank you very much.
Sorry. Let's take like a quick few minutes and reflect on. I know Venkat spent about like 6-7 hours throwing like a lot of information, right? If you just like maybe look back, it's almost like maybe equivalent to 70, 80, maybe 100 hours worth of like maybe knowledge. So take few minutes and see what are the things that you learned, reflect back with Venkat. Anything like maybe say you wanted to share, these are the things like really good. It's also like a little bit like maybe feedback for Venkat. Venkat would like to hear from you, how his time helped you and
love it. Thank you.
Venkat, maybe you can stop sharing the screen. Everyone, maybe if you are like maybe available, start your video cams.
Yeah, anything that that can be improved also. So please, both sides.
Would like to go fast?
Maybe I can go. Venkat, I think maybe, I don't know. I didn't see anything that really you need to improve. You have depth and you have clarity and you have patience. Yeah, thanks for everything what you do. At least my company is using Azure, so I'm trying to want to see what's in AWS also. I didn't spend time. So cross comparing product capabilities between Azure and AWS, and especially some of those things related to the serverless or event architecture, or like VPCs, and all those topics, right? Like initial regions and how those within the regions, what is it? I forgot the keywords.
Availability zones.
Yeah, availability zones. Yeah, I got more clarity on that aspect also. Thank you. Thank you so much.
Oh, you're welcome. I love doing it. So it's.
Next I'll go. Hey Venkat, sorry. So
no.
last time also I told the same thing. Even I don't know. I am zero. We are using the Google Cloud, and that this is the AWS. I don't know anything of this AWS, but really when I see your when I see and listening your classes, it's really I'm working in AWS. How to work in AWS, how to create, how to log in, everything I learned basics from this one. Thank you very much, Venkat. So I'll see you in future.
Yep,
Really.
glad to hear.
Very soon, Venkat.
Absolutely. No, it's thank you, Anil, for your kind words, and glad to hear you got something.
Yep.
So
thank
absolutely.
you very much. Yeah, thank you very much for spending this many hours with us.
Absolutely, I love it. I'm passionate about it. So,
would like to go next?
Hey.
There are tons of videos available in YouTube. The difference here, right? The customization, like what is really needed to the exam. So you just nailed it, and especially the complex topic, VPC. I just loved it, and subnet, private, public, NACL, security group, all of that, right? And even so deep, and what is really needed for the exam. So awesome. Not just AWS knowledge, right? And also you're prepping the audience think like an architect.
Right. Exactly. That's
knowledge. I don't think
that's a good point.
Watching the video. So thank you.
Thank you, Anand,
Amazing.
for your kind words. So on day one, this is what I tell them, right? I have a couple of objectives for them. One is I give them all the like a required AWS services, the landscape of all the AWS services,
Right.
and then prepare them as a cloud architects. That's how I, envision on day one, like how Vamsi envisions us, right?
Mm-hmm.
So exactly, I envision them as cloud architects, and then everything needed. So a lot of them are developers, okay, but I just build that. So I take them towards the journey, and how do you think like an architect, and especially cloud architect.
Yeah.
It's a cloud architecture it's slightly different, right? You have to be prepared for the failure.
True.
So it's thank you.
Absolutely. That's a good one. And you created, so much interest on the event-driven architecture also, which is the way to go, right? And that's the future. So
right.
You just nailed it. API gateway and a lot of real stuff, the latest and greatest technology. So it's going to help everyone.
Thank you.
Thank you.
Appreciate it.
Before these calls and meetings about these AWS sessions, I am afraid to say I'm a beginner in Azure solution world, but right now I can say I'm intermediate, definitely. After implementing all this, I can say like I'm an expert too. So thank you so much, Venkat, for that.
Love it. Thank you so much for the kind words. Yeah. Appreciate it.
Anyone else? I know a couple of you directly working with Venkat.
Yeah,
I want to hear it from Srinivas.
He's not here.
He's not here? I see
Yeah,
him.
he's not here.
Oh, it's a different Srinivas.
Oh, okay, got it.
Nara,
Folks that I
had already given my valuable comments to our Hari Venkat. But I have to repeat the same. But you're the best, Venkat, again. This is third time I'm repeating. Thank you.
Thank you.
But at final, I have an opinion-based question to all. So I'll be asking it last, not now.
Sounds good. Yep. Thank you, Nara, again.
So if everyone is done, and I'll ask my question. So the thing is, if you see the industry and this all the cloud, right? If you see the AWS or Azure or any other the cloud technology, Google or Oracle or whatever, the people has an understanding or the impression that this is a sort of a networking architecture. So this is required only for the network architect. This is not required for the real application architect or the language architect or whatever. So is that true or is that false? But if you want my opinion, I'll tell my opinion up front. Okay. My opinion is this cloud architecture is an evaluation stage. Now at that, now at the networking stage, it is not yet evaluated. It is, I can say, in different words, it's in a mature stage. So it will be matured little later if you see the Lambda expressions and all this different sort of stuff. I think in future it will be evaluated like anything, but right now it is on the networking stage. So what is your opinion? And if someone can share some sort of information or knowledge here.
I have my thoughts, but I think I would like to listen rather than throwing my comments. So Shashi and everyone,
Actually, I didn't listen that, like I was typing something else.
So is AWS only for the network architects, or is it really in the infancy state? Not necessarily AWS, but overall the cloud architecture. Where are we with that in the big, in the big picture? Is it really in a matured state right now, where big organizations can jump in. I know I paraphrased it a little differently, but I don't know if I captured that right, Nara. You can correct me though.
Okay, he dropped.
Looks like he dropped.
Oops. Okay.
Yeah.
I think that's how I understood it. I wanted to differ it, but I wanted to differ it that in a way that it's actually, except your AS400 and mainframe based applications, in my opinion, there is probably no reason to have your, on-prem, unless you are like a Dropbox-like company. See, Dropbox, it's a very interesting use case, right? Dropbox was completely built on S3. If you look at the Dropbox was completely built on S3, and that's where they lived there for probably more than a decade. And then 2 years back, they built their own data center to save the cost. Obviously they can architect it because they have a very niche use case, specific area. So unless you have something like that, really, it's for everyone, especially DevOps is helping in a way that there's no more difference between, developers and operations, development team and operations team. Pretty much you can, you spin your servers. Especially, I forgot to mention AWS topic called cloud formation. So using the cloud formation template, you'll be able to build the entire infrastructure with a single script. So that's the beauty of it.
I mean, main intention also, right? I think maybe is it need to mature more enough? Means obviously it need to be like when people are using it, then only it will mature more.
Right.
When people are more, everything become so. Like expectation from the business side and the way how industry is going on is like everything they want to be delivered very quickly. So obviously the people are more focusing on the DevOps and smaller chunks of functionality to be delivered quickly so that it will add value to the business. At the time, the focus needs to be more on the functionality, and obviously people need it. I mean, there are like legacy core fundamental systems like maybe Airline Saver is like there exist. Those are mainframe systems. So those immediately you can't change it. But majority of the businesses like startups or mid-level companies or even corporate companies, major functionality which serves to the customer needs to be changed so quickly. Like you need to adapt to the requirements. You need to adapt to the customer requirements. If you want that to be happen, obviously you need to be in the digital transformation journey of this all this cloud, DevOps, and Agile. Then only you will be able to capture the business, and then only you will be in the market.
Right? Your time to market is so less.
Yeah.
Your time to market in this competitive environment, if you're not up, it's agility, right? So that's where your agile, framework comes into picture. So you want to ship out, you want to ship to production once a week. Actually, Facebook does it few times a day.
Yeah, even I think Amazon is saying like they will do around 450 or 600 deployments every day.
Right. Yeah.
Even our team, right? Like in our team, like from like maybe a year and a half back, we used to do monthly one deployment, like a gigantic ship goes with huge deployments. And now with 6 squads in our team, like we do at least 8 to 10 deployments every day.
Yeah.
Venkat, my opinion is like AWS is for not only for the network engineers, it will help even application developers. As Shashi said, like business always expects like beyond development. So in right now in wherever we in my organization also, they won't expect just develop your part and then deploy and then you are done. No. Unless it's working in production, that's your responsibility. So this way, like AWS, so how we have deployed, and load balancer, all the things you just now you explained, right? So whether it is in the correct place, it's working fine. So it's not only for network engineer, I feel like that. So it's very useful.
In the book Linchpin, thank you, Anil. In the book Linchpin, he mentions that Seth Godin, I think, right? He mentions that shipping is more important than anything else. So it doesn't matter if you're an artist and keep looking at the defects and keep making it perfect. And if you're not going anywhere, it doesn't matter. The world doesn't care about it. Ship fast.
How
Get it
quickly
out
you're
the door.
adding value.
Get it out the door. Absolutely. So it's a value-driven development.
So when you are teaching, Venkat, you believe it or not, I'm just seeing my Hyderabad days when I'm learning Java. So their anxiety, when should I go and do the experiment for the systems? Really,
He's from there. He's from there.
really, the way teaching, you have that skills. See, teaching, you can teach in 10 different ways, right? So the way you are teaching, so everybody can understand that. Simple, and then it's going sharply into your mind, in our minds.
I think
you're able to
your
create the
passion is
excitement.
really good. Like when you're saying something, you really, we can see that in your eyes and your voice. Like you want to deliver it in a way so that the other person catches it really, really well. It's really good. It's a rare thing that we can find with somebody. There are a lot of people who can teach, but not with the passion and zeal that I see in your eyes. That's for sure.
Really appreciate it. Really appreciate it. Thank you. Means a lot to me.
So every time,
Deepak, you can turn on your camera. We can see your face. We want to see your face.
So every time, when you talk about the same topic, right, you will have the same energy level and the excitement. So that's amazing.
Thank you. Thank you.
Yeah, the passion he has. It's all about passion. Because he has that passion, it's always the same. Even if you wake him up at 2 o'clock in the night, I think he will say the same passion, the same level of thing. Like I never see him getting tired, though he's talking like continuously per hour plus, but still the same momentum, the same level of delivery of the words. I don't see any change in between at all. We might be feeling tired, like okay, we are getting so much of content, but I don't see that in his eyes. He's continuously delivering with the same level of enthusiasm. That's a great quality.
Thank you. Thank you. Thank you. Yeah, I love what I do. I mean, this is my life calling. Is what I believe in. It's
just
great.
one request, guys. I know Venkat did not ask me to do this one. I'm just like, so I know Venkat very well for last like 17, 18 years. I wanted to just like bring this up. If you know anyone, they're thinking about like getting into AWS or like maybe preparing for the certification or wanted to get into cloud, just like maybe send them across to Venkat. Venkat is passionate about, you already saw this like in the last like maybe 10 hours, 7-8 hours of videos, how passionate he is and like how good he is. So help him to help more people. It's not just like helping Venkat, you're helping your friends.
Yep.
I appreciate it also. Thank you, Amsi. I will say
that. Just want to hear one thing, Venkat. Like, how are you seeing it's going to evolve in future? We know what we spoke and what you said, but I wanted to hear like being a solution architect and working on the cloud these many years. I'm just trying to understand how it's going to evolve in future and what they're going to be adding in future. If you have any thoughts or inputs on it.
I may have a thought or two, but I want to hear from others also. So
sure.
My viewpoint is that, so specifically AWS, let's talk about it. It's not specific, but I'm talking about, there's something called, we talked about Lambda, right? There is a new concept that they released recently called Lambda at Edge. So running the Lambdas at the edge locations closer to your edge computing is another, right? Edge computing. So they have taken this Lambdas at the edge, meaning if I'm making a request in Detroit, from Detroit, right? So there is a nearest edge location, let's say in Detroit. So my compute will happen in Detroit. So that's one, I know specific item, but I like that. And
absolutely makes sense. Yeah.
And a couple of other aspects are, I'm more interested in how this AI is going to, transform AI and machine learning along with big data. So with all the data that we have what wonders can we do? Especially my company now, my current company, we are heavily relying on this big data. This data that we have a strong analytics team. We use this SaaS and using the data. So it's all about using the data and then making sense of it. Of course, bring the artificial intelligence into the mix is my not a future term. I mean, not a long-term vision. I think
immediate future.
Probably in the immediate one. Yeah, Shashi, right? You said it rightly. So these are the three things that I'm excited about. But I don't know. You guys.
You're right. You're right. Actually, whatever you said. Actually, in American Airlines, they are trying in the airports, every airport, because initially they did like gathering all the pieces of IoT information from every airport to the servers.
Right.
Now we are I don't know the too much details, but I was in the architects committee, so I heard from one of the implementation they are doing in airports is like they are doing this edge thing in the airports and getting the final data into the centralized, of course, AWS. To do final things.
Right.
I mean, I think a lot of times like you said, like it's all about like we are generating tons of data on top of it with IoT. It become more evident, and we are not seriously not using that enough data, and there is plenty of opportunity to get out of that with the customer behavior and make it like more appealing business to gather the customers. And you nailed it, like analyzing the data, analyzing the using artificial intelligence and machine learning and providing more features. And I mean, people are still doing it in the DevOps and digital transformation, right? Like they are delivering the features based on the customer response. You need to tune your product accordingly, but they are not doing it efficiently and fully there. So that's going to happen immediately, like how customer is reacting, how customer is using, how analyzing the customer behavior and adapting it quickly in the next MVP, like keep on moving it, right? So at the end of the day, customer will drive what they need it, then business is deciding it.
Right.
So that is fully not there yet. We are using little bit, very 10% of flavor, but I think we need to go 90% there. I felt like that. And a lot of data, people are like in even a lot of companies, still people are not going towards event-driven architecture. Some teams in some companies, a few teams are doing that. Still, there is a huge opportunity to go event-driven architecture and make things simple. And by adding artificial intelligence and adding intelligence to that event-driven makes more with this, especially the cloud-based architecture, you can make things more. I think normal regular projects also will become event-based architecture.
Just wanted to give a quick example. So if you look at like any successful hockey players, they don't go where the puck is going. They go where puck is going to be in few seconds from that point. So that is the metaphor I think we all need to take it. We don't want to go where everybody else going. We need to understand where the future is going to be and go and stand there. I think like maybe investing into this cloud technology, investing into all this like maybe 5G related technologies going to have like maybe different edge than maybe just following the crowd. Everybody's doing AWS, I'll also do AWS. That is not what exactly like going to help us. we need to identify those trends, no matter what industry it is. It's a banking, it's going to be healthcare or transportation. There will be always like edge cases, and identify there and just go and sit there. Automatically Puck will come and come to your code.
Right. Very true. So I mean, I think back then the economy was driven by the gold. Then it was driven by the oil. Now it is driven by the data, right? And there are like tons of
About data.
Yeah, tons of data being generated, and they need, I mean, supercomputers, intelligence, and all of that, right? And that's where the trend for next 10 years at least.
We used to have limitations generating the data. Now, like from last 10 years or something, we are generating data.
Right.
But now it's time to use the data.
Intelligence, yeah, out of it, yeah.
To start monetizing it.
Yeah.
Yep.
Thanks, guys. Thanks for all the inputs.
No, thank you.
Thank you, Momsi.
Yep. Awesome, guys. This is really great, Venkat. Really, I know a lot of people are going to be watching these replays and taking a lot of notes. Again, thanks for your time and showing your leadership. Really appreciate it.
Anytime, Momsi. Thank you.
Thank you.
I love it.
Thank you.
And these 3 videos, all the review videos, I put them in my website, Next Step Training. Go to AWS training videos. There is a separate section I created it, the review videos. So watch them,
Sure.
Okay, the third one also I'll upload there once Momsi send it to me.
Absolutely. Excellent, guys. For Mastermind team, we missed our planning session this week, but you know the drill, right? You know the protocol. So go and spend next like maybe 15-20 minutes on your own, complete your weekly planning, and execute that.
So
Sure, Momsi, and thank you for the 400 push-ups, challenge. And Anand, I want to hear from you. How many did you do? 800?
400? No, come on.
Okay.
That is Momsi.
That's
how you guys are doing it, man. You and my brother, like you guys are like killing, and like my hands are like crazy now, like just for 200.
Deepak, how are you doing?
Yeah, doing good. Right now at 75.
25. Good. Arun, how about you?
I'm done with my 100, but I'm not going to stop planning to do some more tomorrow.
Very good.
There you go.
Let it go.
Excellent, guys.
To go. Do
for people who are not part of the mastermind, it's always say you can get into the peak state by just like doing some kind of like maybe workout or like maybe some kind of like a routine. So it's in your hand. Maybe Venkat can help you during your like a one-on your Java sessions how to get into the peak state.
Right.
So once
I will add a sentence there, Vamsi.
Sorry?
For the people who are not familiar with the group, right?
Mm-hmm.
I will add a sentence there saying, these weekly challenges are a great way to really get back in the game. So with the mastermind, one thing I wanted to add is, like other people, like everyone else, we also have ups and downs. This is from my perspective. Okay, I don't know about monsters like Anand, Vamsi, but my regular human beings, right? Like me, I have my ups, I have my downs, right? But the point is, when I'm down, you guys are always there. Maybe a day or two I'll be in that state, but after that, looking at you, I just get back, and that's what gets me going. So that's what I love most about the group here, about the mastermind. And Vamsi, as I always say, I'm eternally grateful to you. Thanks for everything. And this challenge is just one of them. There is no way I would have, it would have occurred to me that I can do 400 in 2 days, 400 push-ups in 2 days. It's raising the bar, continuously raise the bar, and then push the boundary, as you say.
Absolutely.
So yeah, thanks for pushing my boundaries and everyone's boundaries here, I think.
Yeah.
Absolutely, Venkat. This is something that I always tell everyone. So we have a supercomputer sitting in our home, but most of the time the supercomputer is not connected to power. So what we are doing in this mastermind is we are basically like giving supercomputer some work, so it'll do what it's supposed to do. So that is all about this mastermind. And also say we all have unlimited potential.
Yeah.
Most of the time we are settling it for maybe fraction of what the potential is. We are thinking, oh, I can't do more than this. I can't because none of my friends are senior executives. None of my friends are millionaires. None of my friends are doing marathons, right? So those are the limitations we are always setting. So once we eliminate those limitations, I think we can do many things.
So what I realized is my Ferrari has always been in garage, not utilizing it. So it's
Exactly.
Very true. Nice way to put it.
I never thought that I can run in a weekend half marathon without any single practice, just by pushing myself. The only reason is either Vamshi, or in the news article somebody is saying in India a lady with a pregnancy walked for 150 kilometers. So I thought, like, just imagine both of you guys and did it. That's it.
Right. Awesome.
Thank you.
Vamshi, sorry, Venkat, your website is nextsteptraining.org?
No, nextstep.training.
Okay. And .org? Or
No,
just,
.training. That's a top level domain itself is
okay.
.training.
Oh, okay.
Maybe Venkat, you can post it on the chat here.
I will do that. Okay. Nextstep.training. NEXTEP.training. Did you get that?
Oh, okay. I was trying to do full next step.
NEXTEP, there is no S there.
Okay, got it. Thank you.
Yep. Wonderful. Thank you so much again.
Yep.
Thank you. Bye-bye.
I'll post the recording, Venkat, so you'll have it.
Sure,
Yep.
Sure, Thank you.
Bye-bye.
Bye, guys.
Thank you all.